A modern war can be won or lost because of a machine that fits inside a backpack. Decades ago, this idea would have sounded like science fiction. Today, a device that fits in a backpack can destroy armored vehicles, shut down supply lines, and completely change the balance of power. Modern wars are no longer decided only by tanks, jets, or soldiers on the ground. This is the story of how drones rewrote the rules of modern warfare. For most of modern history, military power depended on three things: manpower, heavy equipment, and air superiority. Aircraft were expensive, pilots were irreplaceable. Intelligence was slow and limited. Decisions were made with incomplete information, and mistakes were paid for with human lives. Battles were decided by large formations of soldiers, by the immense power of armored tanks, and by the thunderous roar of piloted fighter jets. In this old model, information flowed slowly. Commanders relied on maps, radio reports, and photos that were hours or days old. This inherent delay created a fog of war about the enemy's location, strength, and intentions. Decisions based on incomplete intelligence led to costly mistakes and missed opportunities. The battlefield was a disconnected and fragmented space, where the view from the top was always blurry. It was a slow, heavy, and often blind contest of industrial force, a world away from the instant, data-rich environment that was about to emerge. Victory belonged to the side with the most men and the heaviest metal. That paradigm is ending. The introduction of drones was not merely the addition of a new type of aircraft. It represented a fundamental systemic shift in military technology. A drone is not just a pilotless plane, it is a complex, integrated system. Several critical components work together to create a capability greater than the sum of its parts. At its heart is the airframe itself, the physical body of the drone, which can range from a small, handheld quadcopter to a large, winged aircraft with the span of a commercial jet. But the airframe is only the vessel. The true power comes from the technologies it carries and the network it connects to. The first key element is the sensor package. Drones are flying sensor platforms. They carry high-resolution daylight cameras. They carry thermal imaging systems that can see heat signatures at night. Sometimes, sophisticated radar that can peer through clouds and foliage. These sensors collect a constant stream of data about the world below. It is a rich, multi-layered source of intelligence. The second component is the communications link, often robust and encrypted. Tactical drones link line of sight to a soldier's tablet. Larger drones relay through satellites, enabling near real-time global connectivity. At the tactical level, where soldiers engage in direct combat, drones have provided an unprecedented advantage. Small portable drones, micro-UAVs, mini-UAVs, have become standard equipment for infantry squads and platoons. Lightweight enough to carry, deployable in minutes. Once airborne, it becomes the unit's on-demand eye in the sky. Look over the next hill, scout a dangerous alley, or survey a building before entry. Before tactical drones, reconnaissance was slow, dangerous, and often meant contact before a full picture could be developed. Now, a drone can silently hover above an enemy position, confirm their numbers, confirm their weapons, and confirm their disposition, while the friendly unit remains safe and covered. Real-time intelligence lets leaders maneuver more effectively and strike with greater precision and surprise. The drone has extended the soldier's senses beyond eyes and ears. Its live feed can guide artillery or mortars with pinpoint accuracy via over-the-air adjustment, drastically reducing rounds needed and minimizing collateral damage. Loitering munitions combine reconnaissance and attack, circling, waiting, then diving with a small warhead, giving small units organic precision strike. While small drones transform the tactical fight, larger drones revolutionize strategic operations. Long-endurance platforms like the Global Hawk and the Reaper are the size of small passenger jets, designed to fly for more than 24 hours at altitudes above 50,000 feet. From this vantage, they can survey vast swaths of terrain, monitor military movements to the activities of specific individuals. They are the modern equivalent of the Cold War spy plane, with no pilot on board. A global hawk can launch on one continent, fly to another, and map an area for a full day before returning. Persistence outmatches manned aircraft. Crews rotate in shifts from afar. Commanders maintain an unblinking eye, tracking targets and patterns of life for deep intelligence. Beyond ISR, many strategic drones are armed, laser-guided bombs and Hellfire missiles. Hunter-killer capability. Find, track, and engage in a single mission. Teams spend hours observing, confirming identity, and striking at the optimal moment to minimize civilian harm. Strategic drones cost a fraction of stealth bombers or fighters. The political cost of losing a drone is far lower than losing a pilot. Lower thresholds and secrecy have enabled persistent, low-intensity conflict, often without the debates tied to deploying troops or piloted airstrikes. One of the most disruptive effects of drones is on asymmetric warfare, conflict between actors with vastly different power. Cheap, commercially available drones have begun to level the playing field. Small quadcopters, bought for a few $100s, can be modified into effective military tools. This grants reconnaissance and even attack options to those once denied air power. A simple drone can scout defenses, track patrols, and identify vulnerabilities. Ambushes become more precise, evasion more effective. Seeing from above erodes the traditional advantage of conventional armies. With DIY changes, drones can drop small explosives like grenades or mortar rounds. Small payloads, big psychological and tactical impact. A well-placed grenade can disable multi-million-dollar equipment or destroy aircraft on the ground. Armies disperse and increase overhead protection, reducing efficiency. Shooting down cheap drones with expensive missiles is unsustainable, especially against dozens or hundreds. This drives investment in cheaper counter-drone tech, microwaves, lasers, electronic warfare. The cheap drone has become a great equalizer. The adoption of drones forces militaries to rethink doctrine. Traditional hierarchies are challenged by real-time information at the edge. A junior leader with a drone can see more clearly than a distant general. Militaries are shifting toward decentralized command and control. The heroic fighter pilot is joined by the remote operator. Engineers, software developers, and data analysts are now critical. Better algorithms or more resilient networks can decide battles. Soldiers must master weapons, and also tablets, software interfaces, and radio data links. Electronic warfare, jamming the enemy while protecting your own, is as important as fire and maneuver. The modern battlefield is a struggle of signals as much as explosions. New tactics. The drone screen scouting ahead of maneuvering forces. Loitering munitions suppress defenses and hit fleeting targets. Planners now consider integrating hundreds or thousands of drones. Doctrines center on human-machine teaming and networked warfare, where every soldier, sensor, and weapon is a connected node. The drone revolution is far from over. The most transformative changes may still be ahead. The next frontier is autonomy, artificial intelligence, and machine learning. Future systems will execute complex missions with little to no human intervention. Swarms, dozens or hundreds acting as a collective, can overwhelm defenses. AI recognizes threats and makes tactical decisions at machine speed. Fully autonomous weapons raise profound ethical and legal questions. The next battlefield will be defined by who controls information and automation. Drones didn't just add a new weapon to warfare. They changed how wars are planned, fought, and understood. Modern warfare is no longer about force alone. It is about engineering systems. The future of war is engineered.